Welcome to the ET380 lecture video for the FM radio receiver. Here's a schematic for the FM radio receiver. This is a kit from Elenco, and they come with an FM kit, AM/FM kit, and an AM kit, and it's an excellent way to learn soldering and how radios work. This one is similar to the one that we use for AM, except here we're going to use an IC for our audio amplifier instead of our transistor circuit. Here's a block diagram of our FM receiver, starting with an FM RF amplifier, a mixer, FM oscillator, automatic frequency control, first and second IF amplifiers, and an FM detector, and audio power amplifier, and the speaker. Here's the FM RF amplifier, and it takes the signal from our antenna and amplifies it. And we select that station with this Gang FM tuner and the circuits, and we have a band pass filter which allows that signal to go through. And this is the amplifier parts, the red. So it's basically just a transistor amplifier, and it passes it on to the next stage. Here's the FM oscillator, which matches our frequency, and it oscillates about 10.7 megahertz above the radio station. So here's our tuner is getting tied to the FM amplifier, and it uses that frequency above the station. Here again, the red is our amplifier section, and it passes it on to the next stage. Here's our FM mixer circuit, and its job is to mix the signals, and it says they're heterodyne, which means mixing, with the local oscillator. So we have it coming in from the RF amp, the FM oscillator, they're mixed. Here's our amplification circuit, the red part. Green is a bypass capacitor, which bypasses noise on our DC line, and it goes off to the first RF, IF amp. Here's our automatic frequency control circuit, and it's using a varactor and this filter circuit, and it's used to maintain the 10.7 megahertz center frequency. Okay, here's our first FM intermediate frequency amplifier, and what we have is we're passing the signal through, and here is a bandpass filter set at 10.7 megahertz, and here is our bandpass pattern here. And this guy is a transformer with a capacitor inside. It is T2 and T3, and there's a diagram there, and it's set at 25k ohms and 4k ohms and 4.5 microhenries. So this one is the band pass filter that passes our intermediate frequency. The green capacitors are bypass capacitors, which take the noise off of the DC battery line, and this one here is a bypass for this resistor, a swamping resistor for our power amplifier. So all the blue, or excuse me, red, are part of that amplifier circuit. Here's our second FM intermediate frequency amplifier. It has the same transformer and essentially the same circuit. It's amplifying that intermediate frequency and passing it on to the next stage. Here's the FM radio detector, and its job is to amplify the audio which is detected from changes in frequency. Remember that FM is frequency modulation, where the frequency changes. This identifies that, and the ratio detector has built-in limiting action which limits the signal, so we remove the noise. This is a T4 and T5 transformers. Here is the amplifier circuit, transistor, and the two resistors. Green capacitors bypass noise to ground from our battery circuit, and this goes off to the audio and AFC. Here's our audio amplifier, and it's using an LM386, which is a standard IC audio amplifier. It's available in just an IC, and it replaces all that transistor circuitry we looked at on the AM radio, and it is very available and does a good job. Here's our earphone jack and our speaker, and this one just amplifies that signal it receives from the rest of the circuit so we can hear it.